Your electricity doesn't travel straight from a power plant to your house. It takes a vote. And right now, a new class of voter with extremely deep pockets just showed up, and they're not interested in compromise. Nearly 50,000 people living around Lake Tahoe, one of the clearest lakes on Earth, are about to lose reliable power. Not because of wildfire. Not because of drought. Because a spreadsheet somewhere decided that ChatGPT needed the electricity more. Here's what happened. NV Energy, the utility serving parts of Nevada and California, has been quietly redirecting electrical infrastructure to serve new data centers being built across the region. Residents near Lake Tahoe received letters warning of potential power disruptions, possibly rolling blackouts. Some communities at 6,000 feet elevation, where winters are not a metaphor, could lose reliable heat. The utility described this as a consequence of regional growth. Residents described it differently. A single large-scale AI data center can consume between 20 and 100 megawatts of electricity, continuously, every hour of every day. That's enough to power a small city. Except instead of a city with schools and hospitals and grandmothers who need their oxygen concentrators, it's a building packed floor to ceiling with graphics cards thinking very hard about what a photo of a cat should look like. The electrical grid was never designed for this. For most of its history, it was a slow, predictable system. Utilities planned capacity growth in decades, not quarters. Data centers broke that model. Their demands are massive, sudden, and geographically concentrated. A single new hyperscale facility can hit a regional transmission network harder than building an entire new suburb, but a suburb at least takes years and requires permits and community input and occasionally a very angry town hall meeting. To understand the scale, imagine filling a bathtub. In 2010, AI was a slow drip. By 2023, someone replaced the tap with a fire hose. Global data center electricity consumption is projected to double by 2030. Every image generated, every chatbot query, every document summarized, each one is a small withdrawal from a shared energy account. 48,000 Lake Tahoe residents did not agree to co-sign that loan. This is an infrastructure triage problem. Utilities can't upgrade transmission lines overnight. Steel, permits, environmental reviews, years of work. So when demand spikes, someone gets deprioritized. And historically, residential customers in rural and semi-rural areas absorb the slack. They're geographically dispersed, they organize slowly, and they don't have lobbyists who golf with state regulators. What's happening at Lake Tahoe is a rehearsal. Across the American West, communities are quietly discovering they're competing for grid capacity with server farms. Virginia has entire counties reshaped by data center sprawl. Arizona towns are watching aquifer water get routed to cooling towers. This isn't a utility story or a Nevada story. It's the same story, playing out in every geography where the infrastructure of one era is being asked to carry the weight of another. The question isn't whether AI needs power. It does, at a scale that is genuinely difficult to comprehend. The question is who pays. Right now, the math works like this: the benefits of AI flow globally, to shareholders and users scattered across continents, while the costs land in specific zip codes. 48,000 people at 7,000 feet of elevation didn't choose to become the load-bearing wall of the generative AI economy. Nobody asked them. That's the part worth sitting with. Strip away the infrastructure jargon and what remains is a three-part accounting problem: benefits that travel at the speed of the internet, costs that stay bolted to a specific zip code, and a grid that was never designed to adjudicate the difference. 48,000 people near Lake Tahoe didn't lose reliable power because the system failed, they lost it because the system worked exactly as designed, prioritizing concentrated high-value demand over dispersed residential load. That's not an accident. That's a policy choice dressed up as an engineering constraint. The data centers will keep coming. The grid will keep struggling. And somewhere in the American West, another community is already receiving its version of that letter. What strikes us isn't the inconvenience, it's how naturally we accepted the trade-off before it was ever offered as one. We generate images, summarize documents, run chatbot queries, and most of us never think about where the electricity comes from or who doesn't have it because we used it. That's not malice. But it might be something worse, a structural indifference built so quietly into the system that questioning it feels almost unreasonable. The Lake Tahoe story isn't about villains. It's about a civilization deciding, without quite deciding, that some people's comfort is infrastructure and other people's comfort is overhead. So here's what we keep coming back to: if the costs keep landing on people who got no vote and no share of the upside, at what point does that stop being an externality and start being a choice we own?